Hi everybody, Jeremy Blum here. Excited to be bringing you a new series of tutorials sponsored by Element 14 and CadSoft, all about using EAGLE. EAGLE is a PCB design software tool that you can use to generate schematics, make board layouts, and get PCBs manufactured. I've used it very frequently in my Arduino tutorials, and I've also used it in a lot of other projects. This, for example, is the MakerBot Mighty board. This is the motherboard that powers the MakerBot Replicator 3D printer. This is a board I designed a while back for MakerBot. It's designed entirely in EAGLE, and it's a fairly complex board, and you can get even more complex than this in EAGLE. Another example of something I've done in EAGLE is actually the header for my website. If you go to jeremyblum.com and look at the header, that was designed entirely in EAGLE. I made the schematic, and then I made the layout for it. And I used one of the very many plugins available for EAGLE, in this case EAGLE 3D, to export a 3D render of it that I'm then using as the header of my website. But for the purpose of these tutorials, we'll focus on schematic design, and then layout, and then getting the PCB actually manufactured. To make that as simple as possible, we'll choose a simple design that we can use along the way. This is the design we're going to work on. It's called the Blinky board. It's something I made a little while back, but we'll use it for these tutorials. Basically, it's just a simple little watch battery, a 555 timer, some passive components, and some LEDs that blink back and forth. So we'll walk through first how to do the schematic of this, how you wire all the parts together in a virtual fashion, then how you actually do the layout on the board, and last we'll talk about how you would get the PCB manufactured. Okay, so let's jump into working on the schematic. If you haven't already, the first thing you'll need to do is actually get a copy of EAGLE. There's a free version of EAGLE that you can download online at CadSoftUSA.com. Navigate to the website, go to Downloads, and download the free version of EAGLE. Free version of EAGLE has certain limitations, but it will be more than enough for a lot of the stuff that you probably want to do on a hobbyist level. Download the file and follow the instructions to install EAGLE. If you do have a licensed file, you can choose to set it up here. If not, you'll probably just want to run it as freeware or choose Don't License Now. Once you've gotten EAGLE installed, open it up and you'll bring up the EAGLE control panel. Here you have access to all of your library files. So these are all of the parts that are available to you that come by default with EAGLE. I'll show you how to add more to this a little bit later. Design rules, these specify the rules for laying out your board. User language, programs, and additional functionalities, scripts allow you to automate things. CAM describes how you eventually export the board to Gerber files that you can use for fabrication. And most importantly, our projects. This is what we're actually working on. Before we start our own, I'll show you what a final product kind of looks like. So this is the finished Blinky board. I'll open up the Blinky board schematic file. There's two files, a schematic and a board file. The schematic looks a little something like this. Basically, this is what we'll be making as a 555 timer and astable oscillator configuration. I won't go into the concepts behind how I came up with this circuit. If you just Google astable oscillator, you can learn all about how 555 timers work to create a square wave that we can use to control some LEDs. But it's very simple. So basically, there's a 555 timer, some passives, capacitors, and resistors that determine the rate of oscillation, two LEDs that blink back and forth, and a little connector for a lithium-ion 3-volt watch battery, and that's this right here. And this is automatically linked to a board file that I've already designed that looks something like this. You can get a lot more complicated with these files. Obviously, you could do a ground pour, for example, but I didn't do that here. I just kept it very simple because I want to keep it relatively easy for this tutorial. You can see here the LEDs, the resistors, everything's labeled. This is the 555 timer. This is where the battery goes, and you can also add custom text. So I added my name and Blinky board. One of the important things to consider here is we'll need to take some time to think about the size of the components that we're using. So there's the schematic view and the board view that looks like this. In this case, I used all 0805 size passive components, and that refers to the size of the actual component. But we'll talk about that a little bit later when we're actually doing layout. Okay, so this is kind of what our final project is going to look like. Let's now go ahead and actually start to make our own from scratch. Today we'll do the schematic. The first thing you want to do is make a new project. So let's go ahead and do that. Right click on projects and hit new project. That'll make a new project folder. By default, it's in the in Windows, it'll be C, program files, Eagle, projects, new project. But you can add additional directories for projects if you click on options up here and add that to your directory. But for now, we'll just put in the default location. I'm going to call it Blinky Board New, because this is the one we'll be working on. Okay, and we've created our project. Now, it's good practice to add some kind of description here. You can use HTML formatting to make this look pretty. So like B for bold tags. So we can say Blinky Board links. This is a Blinky Board PCB. Okay, and we'll put that in paragraph tag so it goes to the next line. This is just something to make it look nice. Okay, hit OK. So now it'll show up over here with more information. So now that we've got that project, that's great. Within that project, the first thing we're going to do is make our schematic. So right click on it, hit new schematic, and the schematic window pops up. Maximize it, and we're ready to start adding components. I mentioned earlier that I wanted to use a battery clip holder that's supplied by Adafruit Industries. Luckily, Adafruit has an Eagle library that you can download from GitHub that has designs for basically most of the components that they sell. So I'll show you how to add an external library. It's useful in this case because we want to use a particular component, but it's good to know how to add an external library in case you find other open source libraries online that you want to use to add component footprints and schematic parts. If you go to the Adafruit GitHub page, I'll add a link to this in the video description, you can download the zip file of the Adafruit library. I've already done this. So if you open up the zip file, there's adafruit.lbr. You'll go ahead and copy this to the location of your Eagle installation. In this case, it's, for me, C, program files, Eagle 6.2 library. So copy this file in. And once it's in there, we have to tell Eagle that we want to use it. So we'll go to library, use, and I usually just hit Control A and select all of them and hit open. And that makes sure that everything that's in there is available for use as a library part. So it'll take a few seconds, process, and import all those. And now we're ready to start using components from the Adafruit library. In addition to the battery, I'm also going to use the footprints that they supply for 0805 LEDs, resistors, and capacitors, just because they're there and it's easy. But you can get those from other libraries as well. Click the Add button in Eagle in order to start adding components to your schematic view. Once the library window opens up, you can see all the libraries that are available to you. There's a lot. Be sure to use the search functionality if you're looking for something in particular. You can enter a search term here. But now I know that I happen to be looking for a part from the Adafruit library, so I'll go up to Adafruit. And the part I'm looking for is for a CR1220 battery holder. Here it is. And if we click on that, you can see that it brings up some information on the right side here. There's two options. One of them is a through hole, one of them is a surface mount. I'll be using all surface mount components today, but you can feel free to use through hole as well if you feel like you'd be more comfortable soldering that. But anyway, we'll pick the surface mount version, hit OK, and it'll add it to our schematic. So I'm just going to drop it there. And it allows you to add multiple, but if you're done, you just hit Escape on the keyboard and it'll go back to the Add window. What I like to do is to first add all of the components that I know I'm going to be using. So the next thing I'll do is add our 555 timer. That's up at the top here. So again, there's a lot of different options based on different available footprints. And these are all very slightly different. And you can see here that the package description changes for each one depending on what you're using. But we'll be using the LM555D, and so we'll click that one. You can see it has a schematic version and the pad layout version that we'll be using later on when we do layout. Hit OK and drop that down. Okay, now we've got that too. The last few things that we're going to need are we're going to need 2 capacitors, 4 resistors, and 2 LEDs. So again, I'll hit Escape. It'll bring this back up. And let's find resistors. So again, we'll look through here, and well, okay, I stumbled upon capacitors first. So let's add those. Here, as I mentioned before, we're going to be using 0805 surface mount capacitors. So let's scroll down until we find that. Here they are. C0805. 0805 again refers to the size of the pad, the size of the pads, the size of the capacitor. The schematic symbol for all these is going to be the same. So we'll hit OK. We're going to drop 2 of those because we're going to need 2 capacitors. Hit escape again. All right, next up we're going to need 4 resistors. So let's hunt for some resistors. That will be under R_US because this is the US symbol for a resistor. Again, we're going to look by the package size, which is 0805. Here we go. There's our 0805 resistors. You can also see that there's a few different variations here. We're going to use the normal one. Hit OK. We're going to need 4 resistors. 2 for our LEDs as current limiting resistors, and 2 to serve in our astable oscillator circuit. Okay, and then it looks like the last thing that we need are the 2 actual LEDs. So again, hit escape. And we're going to look for some LEDs. Here we go. LED. Again, one symbol with a lot of different possible options. So this is like the traditional 5mm through-hole LED, but we're just going to use a chip LED in a 0805 size. Let's see what's the difference between these two. One of them just has a plus sign, one of them doesn't. Just slightly different. Depends on your preference. I'm going to choose this one. Okay, and we need 2 of those. Alright, and that's basically it for all of our actual components. Now that you have all the components set up, the next step is to actually wire them all together. Let's start by getting everything positioned where we want it. Click this Move an Object button up here. Single left click on an object, move it around, and then click again to drop it. If you want to move a group of objects at once, you can use this selection key up here to define a group. So click and drag to define a group. Then make sure that this is selected again. And now instead of left clicking, you're going to hold Control on your keyboard, right click, and that will move the group. And then you can left click to release it, all while holding Control. That allows you to move a group of things. So let's get the 555 timer here kind of in the middle. We'll move the power supply over here. To rotate something is relatively simple. Just click the rotate button and then click on the object and it'll rotate it, and if you keep clicking it will keep rotating. We want it to face up like that, so we'll just face it up. If let's say you want to delete an object, you would click the delete button and then click on delete, but I'll undo that. And you can also duplicate an object by clicking copy an object, click on the object, and then clicking somewhere else to make a new one. But again, I don't want that right now. So it's all relatively straightforward. So let's go ahead and get everything kind of hooked up here. We'll set up the LEDs up here. So we'll get LED 1 up there, a current limiting resistor for it. Let's grab this one. And again, we'll use rotation. So rotate it, place it right there, and then we'll get another LED, stick it here, and then get another current limiting resistor, put it right here. Okay, so those are our LEDs all set up. Just like I showed in the example layout. To define an electrical connection between 2 points, you use this one right here. This one, the sticker one, is for a bus, but we just want to do a single connection, so we'll click on this one. Click once on the end of the first object, drag it around wherever you want it to go, so drag it and click on the end of the other object. And that's how we'll go about connecting these. Now, there needs to be ground here, and so you can kind of do ground in one of 2 ways. You can either just connect all the grounds in the circuit to each other, or you can add a special component that defines a ground and adds anything attached to that net or that signal layer as a ground. So let's go ahead and do that. To do that, we'll click on Add a Part again, and we're going to be adding a special part that's called ground. So let's just search for GND in here. It'll come up under Supply. Okay, and just click ground, and we'll add it down here. We're also going to need a ground attached to the bottom of the battery. So what we're doing, just like when you would draw a schematic by hand, you can have two pieces that aren't actually connected to each other, but are still electrically connected. So we'll connect ground to here, and ground to here. Now, even though these two things aren't shown with a wire connecting them in the schematic, they will still be connected when we go into the board layout view. And that's all that we really care about. And it'll just help keep things a little bit neater. Okay, so then we'll wire these LEDs up to the 555 timer. So those connect to the Q pin. And you'll notice that in this particular implementation, the pin numbers are not in the same order as their actual functionalities. So when you're looking at a chip, normally it'd be 1, 2, 3, 4, but here they're laid out differently, just the way the schematic drawing is done. They'll be connected to the appropriate pins when we go to the board layout view. Okay, so that's all relatively straightforward, and we'll just keep connecting things as I showed earlier in the previous finished schematic. So let's do that now using the same methodologies. When something comes up like this, it's just asking you if you want to combine the two segments because each of the two lines had separate names. You can just hit OK. It's just renaming the actual electrical connection. When we want to add another ground, I can simply use the duplicate option to copy an object. So I'll click on this ground, copy it over here. Okay, so I've finished connecting all the parts, but this still looks a little bit messy. So we can do even a little bit better in Eagle. Just like we added the multiple grounds, we can also have a unified source so that we don't have to connect all the positive terminals of the battery to everywhere. So let's go ahead and implement that. These are just steps that aren't necessarily required. It's going to work exactly the same in the board view, but it'll make the schematic view look a little bit nicer. So let's cancel this search. If we go back to supply, again, I can just hit S and it'll take me to the S's. So we're going to open up supply, and we're just going to get a generic V plus indicator. It doesn't really matter which one you use. If you have a particular voltage level, you can pick that one. But we're working with a 3-volt battery, and I don't see a 3-volt one, so I'm just going to pick V plus, which is fine. You could also grab like VCC. Actually, let's do VCC. We'll do that. So we'll grab VCC and put it up there for now. Hit escape twice to get out of the parts selector. And now let's connect our positive ends all up to VCCs instead of to each other, and that'll remove some of the wiring a little bit. So to delete a wire, just click the delete button and delete the wire. So we'll delete a bunch of these. Okay, so this can get wired right up to here. Again, it's asking if we want to merge this line, which was called $8, so like just a variable 8, into the VCC net. So we'll hit yes. And this line does not need to be that long. So click on this, just drag it down, just like that. And now our battery is kind of this self-contained thing over here. And we can do the same thing with everything else. Just duplicate the supply, set it up everywhere where you want it, and attach a wire. And And then, like, so for here, let's say we don't want these lines crossing because it doesn't look that good. What we can do is we can rotate VCC and put it right in there, just like that. And that just keeps everything looking a little bit nicer. Over here, we could probably make room for VCC on pin 8 to kind of fit into there. So to do that, we'll move everything over a little bit. We can select multiple items like this. And again, you'll just hold Control, right click to move the group. Or you can just move it piece by piece, whatever's easier for you. Again, we'll duplicate VCC so that we can hook it up to this guy. Now that's overlapping, doesn't look that good, so we can just move this over a tad. Okay, that's already looking much, much better, I think. So it's not really necessary in this particular implementation because this is a very simple circuit, but there is one more thing I want to show you in terms of wiring, and that is labeling the nets and making remote connections like that. So let's say we want to connect, so this net over here is connected through this wire over here over to these two nets. Let's say we want to connect them without actually showing the connection. That's relatively easy to do. So let's go ahead and delete this wire. So we want to connect this to this. So what I'm going to do is just make little connectors here and there. And then what we're going to do is we're going to choose to label each of these nets. And by giving them the same name, it will automatically virtually connect them. So you saw before the net names are like $9, for example. So we're going to add this label to that so that it's easy for us to keep track of. I like to choose this little tag thing, which I think looks a little bit nicer. And you can rotate it by clicking one of these buttons and just stick it right there. So now this was already called $9, but now we're just able to visualize it. And I'm going to add a similar tag over here by clicking on this guy and adding the same tag. Now these are not connected right now because this is $9 and this is $5. We want to make them the same. So to do that, we're just going to give them the same names. So here, this allows you to define the name of an object. Click on that, then click on the tag. It'll allow you to make a new name for it. We're going to call it just CONN for connection. Very simple. Ordinarily, you'd want to give it a more descriptive name, but this doesn't really warrant it. So we'll hit OK. It'll say, okay, do you want to connect it to this other net because it has the same name? So you'll hit yes. And now, even though these aren't shown as being connected in the schematic, they will show up as connected when we do the board layout, which is all that really matters. So that's it. This is looking pretty nice now. Now, one last thing that you might want to do is each component has two attributes associated with it, a name and a value. Right now, you're seeing, for the most part, just the name. So like for this one, this is R1, R2, R3, and R4. But these also are different resistor values, and we want to make sure we indicate that so that when we order parts, we're getting the right parts. So to define a value, you can click on this value button right here, and then click on the part. So R1, for example, is going to be a 1K resistor. So we'll put that in there, and now it'll indicate it next to the resistor. R2 will be 100K, and each of these will be 100 ohm resistors. So we'll put in all of those values so that we know that we're using the right parts. And that's important. You'll notice that the 555 timer doesn't have a user changeable value. It's already set to LM555D, so we don't want to change that. That's fine. But we do want to set the capacitor values. So C1 is 22 microfarads, and C2 is 0.01 microfarads. So we'll define both those things so that we can make sure we order the right part and whatnot, and that's obviously pretty important. We can even define the values for the LEDs. So we're going to have them both be green, so we'll say the values are green. The battery doesn't really warrant having a value, it doesn't matter, but we can put CR1220 because that is the type of battery we're going to use. And you can also rename parts. So right now this is R1, R2, R3, and R4, etc. But like this one is $1. That's not very nice. So we can rename that. We'll just call it, we can just call it BAT if we want for battery. And that's the new part indicator number that will come up on our bill of materials when we generate that. More interesting stuff that you can do is using things like the EAGLE user language programs. So let's save this. And you can go to File, Run, and there's all kinds of interesting things here that let you kind of change your schematic. So one of them is renumber SCH. And what this will do is this will, let's say you added and deleted a lot of components, and let's say you have like R1, R2, and R5, but you really just want to have 1 through 3. This will do that for you. So you can click this, and this will renumber the schematic. So we hit that, and we can actually see that it did renumber some of the things. It changed these R1 and R2s because it was going from top left to bottom right. So it actually renumbered some things. And that's actually a very useful script. And there's a ton of scripts. You can go through all of them. They all do very interesting things to help make things neater and stuff like that. Okay, last thing I want to show you now that we're just about done with the schematic is the design link. And this is something we'll cover more in the third tutorial. But design link is cool because EAGLE was recently became associated with element 14, which means that you can do a parts lookup. So this is really neat. So if you click on design link and go to schematic, it will automatically search for these parts in the Newark database and try to help you find the corresponding components that you can use in order to assemble your circuit board. So we're going to skip the coin cell one because we already know we're going to get that from Adafruit. So we'll skip that one. And the capacitors, so for example, the first thing looked up is 0.01 microfarads. Now we know we're using an 0805 capacitor, so let's give it a little bit more information. Hit search. Okay, and that looks a little bit more reasonable. That's a 0.01 microfarad capacitor, 0805, looks fine. So we can select this and it'll add it to our bill of materials. The next thing it looked for is 22 microfarad. It found 22 microfarad 0805 capacitors. These are perfect. We'll hit select. Now it's looking for some LEDs, and it's looking by the green value number, so that's not really what we want. So we'll tell it some better information. LED 0805 green. Let's see what it finds for that. Okay, this looks a little bit more like what we want. So these are little chip green resistors that we can use. It says that the 2.1 volt forward voltage, 0805, that's perfect. Let's select. Okay, now it's looking for the 1K resistors. So let's put in 1K resistor. Maybe tell it it's 0805. Okay, there we go. 1K resistors, 1% accurate. That's perfect. Okay, now, so obviously it doesn't have enough information here. It's looking for the 100 ohm resistors that we're using as current limiting resistors for the LEDs. So let's just tell it they're 0805 resistors. Okay, perfect. So these are 100 ohm 0805 resistors. Let's add those. Now it's looking for an 100K ohm resistor. Again, we want to give it some more information because it's just doing the best it can based on the values I gave it. Okay, these are not 100K. Let's look down the list here. Here we go. These are 100K. Resistor's perfect. All right, and that's it. So now we have our bill of materials, and this is great. So the 555 timer is missing from it, and the battery is missing from it. So it couldn't find either of those things. That's fine. We're going to order the battery clip from Adafruit, because that's where we got the footprint from. But the 555 timer, we should be able to find in an SO08 package. So let's have it try to look for that again. Let's look for just 555 timer. Okay, so this is a TI SOIC 8 555 timer. That looks just like what we want. We should probably check the data sheet to make sure that the footprints match, but for now, I'll go ahead and add this. Okay. So now we have our bill of materials, which is awesome, and that was really fast. If you've done circuit board layout before, you know that's usually really annoying to pick out all the parts. We just did that in just a few minutes, which was really great. So from here, you can even go on to ordering the PCBs and stuff. We'll talk about that in the third tutorial. But for now, we can add these to our shopping cart, or we can export it as a bill of materials that we can use later to find and order all of our parts. And we have the manufacturer part numbers and all that information, which is great. Okay, you've officially designed your first circuit board in Eagle. Good job. The next thing we'll do in the next video is bring this over to the board layout view and actually start to do some layout, some routing, things along those lines. And then in the video after that, we'll talk about actually ordering PCB and getting your parts ordered. So congratulations, good job. Let me know if you have any questions. And this looks great. I look forward to doing the board layout in the next video with you guys.